around the class. And I will start this way. All right? Just because I'm left-handed and this is clockwise, that makes sense to me. So anyone at this table has a question, I'll start. Ivana, did you raise your hand?
Yeah, number 14.
14? All right. So is it something specific, or do you want me to just work the whole thing?
I think I can help you started on that one.
Okay. So, all right. So in this one, it tells you what the substitution is. Not necessarily something that would be given on a test. This is so u is equal to 1 over x to the 5th, right? They're telling you what substitution to make. And so you could rewrite that as x to the negative 5. And then the derivative of that is negative 5x to the negative 6 dx. Right? Do you have that anywhere? X to the 6th on the bottom, right? This is the same as secant squared 1 over x to the 5th times 1 over x to the 6th dx. That's what that really means if I peel it apart. Yes?
I was going to just push up to 6.
You could push that up also. It's up to you. Yeah, you would have exactly this. So either way you look at it, this is also this, right? I mean, it depends on, do you want to use negative exponents or not? If you want to use negative exponents, you can use this. If you don't, you use this. So we almost have it, right? This right here, this right here. So we're just off by negative 5. So we'll scale out a negative 5. Negative 1/5 du equals 1 over x to the 6th dx, right? And I think we can just go straight in, right? Straight in. So this becomes integral secant squared of u, right? That was our u. And then this 1 over x to the 6th dx becomes negative 1/5, which I'll pull out du. Good? Antiderivative of secant squared u is... That's, careful, tangent u, antiderivative. Right? Antiderivative of this is tangent u, but we still have the negative 1/5 out front. So negative 1/5 tan u, and then replace u with 1 over x to the 5th. We're done. If you ever want to watch an interesting video on YouTube, MIT, you all know what MIT, Massachusetts Institute, they have an integration competition with their students, and they videotape it, and they basically put people up on boards, and they put up an integral, and then everyone goes after it. And it's a speed thing. It's who gets it the fastest. It's pretty amazing to watch. It is. Huh? I did the other couple of weeks ago. They put the problem up and I do it real quick, and some of them are really, really tough. Really, really tough.
Like even for you, like you have to actually like use brain power.
You know what? See, I teach at a certain speed because I don't. How do I say this? I have to communicate the idea across, right? This integral right here I probably could have done mentally pretty easily, but I'm not super fast at all integrals, right? And so these guys that are, and girls that are doing this competition, their brains just work super quick. I mean, it's crazy.
Students or teachers?
Students, yeah, yeah. I mean, for the most part, I kept up, but it was still, these are people that just love this stuff. It's like a spelling bee, right? If you're good at a spelling bee, does that mean that you're like a great, you can write great papers, right? If you're great at integrals really fast, that doesn't necessarily mean that you're going to be the best engineer, okay? It's just, you're really quick at that, right? It's just kind of neat to watch, that's all I'm saying. All right, how did I start talking about that? Thank you, Ivana, for the question. I'll move to the next table. Is that all right? Anyone there? Luke or Matthew? Yeah. Okay. Number 7. Yeah, so you know what? 7 did not really come across the way I wanted it to, because I just helped someone out with this, and when I created the problem, oops, hyperbolic. When I created the problem using the software that made this, it didn't show me that second line where it gives you the sign and then the parentheses. I didn't see that when I created it, so I just thought they wanted you to prove this identity. That's all I thought they wanted you to do, is prove this. I didn't realize they were going to try and lead you through it.
No.
Okay? Is that what? Okay, so in your paper, the next thing, it says sine hyperbolic 2x equals sine hyperbolic parentheses x plus then blank, right? That's not what I would want you to do on the test, okay? This is what I would want you to do, and I would state it in here. Prove the identity using the definition of hyperbolic trig functions. What is the definition of sine hyperbolic x? What is its definition? E to the x minus e to the negative x over 2. That's the definition of hyperbolic sine. That's in your formula sheets, right? So if you replace this x with 2x, that gets replaced with 2x, and that gets replaced with 2x, right? So what we'd like to try and show is that this side over here is equal to this side, right? So which side do you want to start with? Do you remember me doing one of these way in the beginning? Yeah. Okay. Probably start with the right side. See what happens? And remember that what we want it to become is whatever this is when you plug in here. So why don't we just jot it down so we know what we're trying to get to. We're trying to get it to become this. Right? That's what we want the right-hand side to turn into. If we can turn that into that, we're done. Yes? Okay. So now, let's start with the right-hand side. So here we go. The right-hand side of this equation is 2 times sine hyperbolic x, e to the x minus e to the negative x over 2 times cosine hyperbolic x, which is same thing but plus between them, right? Over 2. Yeah? I can say at least one of these 2's cancel, right? This 2 that's still here, I can write that as a 1/2 out front. Agreed? This 2 on the bottom is like a 1/2 out in front? Yes? Yes? Okay. And now I can multiply these 2 together, and I can do like a FOIL. So let me try that out. What's e to the x times e to the x? E to the 2x. Well, that's good because look over here. E to the 2x. Right? So I'm going to have e to the 2x. Now, what about the next multiplication? Here to here? That's going to be e to the x times e to the negative x. You add the exponents. E to the 0 is 1. I remember doing that. You remember doing that? So that's 1 plus 1. And then what about this next multiplication right here? It's the same as this, right? But it's minus because it's a negative times a positive. So we'll have minus 1 here. And then what's the last multiplication? e to the negative x, take away x, is negative 2x. The ones cancel, right? Oh, I should put all this in parentheses. And isn't that exactly what we wanted? Yep. That is e to the 2x minus e to the negative 2x times a half, which is the same as this. So that is equal to the left-hand side. Check. Good question.
Yeah, I was just confused by the way.
Yeah, I know. I apologize about that. I didn't realize it until Kiki asked me. Okay, Paul, Chris, Ethan, Robert, Sean. Anyone back there have one? Or since your table has so many people, I'll let you ask two. Unless you don't have any, then we'll move on. All right, we'll come back to you. No? Ruben, anything?
About
16? They tell you what U is, right? On the test that you take on Thursday, I'm not going to ever tell you what U is, all right? I just don't want you to be surprised. Man, on the review, it always told me what U was, and then when he gave me the test, it was, he never told me what U was. That's how it sounds to me when I read the reviews. So they tell you that U is cosine, right? But do you see why? Do you see why it would be? Why you would choose that? What's the derivative of cosine? Sine. So look, this is a basic substitution. You see something in its derivative. Why not pick sine for you? Why not pick sine? Because why? What's the derivative of that is cosine, but it's to the 10th power. You don't ever want the derivative of your u to be stuck and be more complicated than what you chose u to be. You don't want it to be trapped. You don't want it to be in a denominator. You don't want it to be under a root. You sure as heck don't want it to be raised to the 10th power. So u is cosine theta. du is negative sine theta d theta. We have that right here. We're off by a sign. I'll take care of that negative, change this to negative, that changes that to positive. And now the integral becomes u to the 10th. And then all this is just negative du, so negative goes on the outside. And that we just use the power rule, right? So that becomes negative 1/11th u to the 11 plus c. And u is cosine. So I've had a few, yes, question?
Yeah. Can we do this using what we learned last class? Like cosine doesn't need power?
Yes, but it also, sine is an odd power. Right.
Do they both have to be even or they both have to be odd?
No, what is the technique? Remember the technique from last class? There was 3 different techniques. Those were things that you could try. They never guaranteed that they were always going to work. But that one said if they were both even, then you try the power reducing. But if the sign was odd, right, then what does it say to do?
You separate it.
You factor out, right? But see, here you have only one factor of sign, so you couldn't separate out. You see what I'm saying? So I don't believe that would fall into last class. See, that's the type of problem that you get on a test, and you try and do what we did last class on this, and you spend 30 minutes going in circles, and then you realize, wait a minute, that was just a basic U substitution. So, all right, where are we at? Anything? Ernesto? Karen? You got anything? No? Which one? No? Which one? 9? Oh yeah, remember 9? A telephone line hangs between two poles 14 meters apart. What is the shape of that called? Catenary. Catenary. So you have this wire hanging. They have 0, 7, -7. The wire hangs from two poles in the shape of a catenary. This is 5. They give you the actual equation of the catenary. This is it. 23 hyperbolic cosine x over 23 minus 18. That graph is this wire. And it says in part A, find the slope of the curve where it meets the right pole. Find the slope of the curve where it meets the right pole. So if we look at the pole here, do you all remember doing this one? Yeah, we did this, right? There's a tangent line that comes in here, and it meets somewhere right at that point, that tangent line. And so if we extend that tangent line out like this, we are looking for the slope of that line. That's part A. And then part B, it says find the angle between the line and the pole, which would be this angle, theta, the one between these two. Right? So how do we find the slope of that line? What's the slope of this line? That's the derivative, isn't it? So let's take the derivative here. The derivative of a hyperbolic cosine function is sine hyperbolic, or hyperbolic sine function, right? The 23 just comes along for the ride because it's a constant out front. Sine hyperbolic, is it negative sine hyperbolic? No, for hyperbolics, the derivatives don't change signs. So this, and then we have the derivative of what's in here, what's in here, and then now the derivative of what's in here. What is the derivative of what's in here? 1 over 23. And then minus the derivative of 18, which is 0. Is everyone comfortable with the 1 over 23? Yes? That 1 over 23 and the 23 cancel. So all you're left with is sine hyperbolic x over 23. That's the derivative of the catenary, which represents the slope of the tangent line at any point on the curve. So now we want to know what's happening at that point, which means that our, what? Our x is 7. If we move out here to 7, we plug 7 into that, then we know the slope, don't we? So this slope will be equal to this derivative at 7, replacing the x here with 7, which is the sine hyperbolic, or hyperbolic sine, of 7 over 23. And how can you compute the hyperbolic sine? You can use your calculator, right? You could. Or you just do the e thing, but even then you need your calculator. So this will be equal to, how many of you have the hyperbolic sine function on your calculator? Everyone should. If you don't, it's okay. If not, it becomes 1/2 e to the 7 over 23. Is the sign hyperbolic plus or minus? Minus e to the negative 7 over 23. So whatever that is on your calculator. Anybody get that? 0.309? Okay. Just making sure you all agree. So we're getting that y prime. I erased my picture. Damn it. So y prime at 7 is 0.309. Now, how do we get theta? So, do you remember how we did this? Drawing this. Yep, we just drew a triangle, right? We drew a triangle from this picture. We know that to get from this point to this point, it has a rise over run. And we know that that rise over run is this number. So if I was clever and I picked the run to be 1 and the rise to be 0.309, then this line, this triangle would represent that slope, wouldn't it? Rise divided by run would be that number. And now how do you solve for theta in this problem? You know tangent of theta, right? Tangent of theta would be opposite over adjacent. So you have to turn your head this way. Opposite over adjacent. So you're going to do inverse tangent on both sides here. Theta will be inverse tangent of 1 over 0.309. And then make sure you know whether or not you're in degrees or radians. What are you in your calculator? Give it to me in degrees, please. 72.83 degrees? Good enough. What else? Anything else? Got about 7 minutes or so. All right, look, if you go onto our website, our Canvas site, I have a thing called files, right? And if you go in there, there's like old stuff. I do have a lot of older exams in there. The problem with these older exams is that a lot of those covered up all the way through Chapter 6, everything in Chapter 6. But there's stuff in here that has solutions in them. Okay, so like exams with solutions. So if you go look through the exam in the solutions, and you see a problem where I've got an integral, and then over here on the side you see that set up, then you know that required integration by parts. So maybe that was a problem that you can practice. Understand? But if it has a bunch of stuff that you've never seen us do, then I avoid it. Just showing you there's some places you can go to see other problems. But mainly for this test, what I want you to focus your attention on to prepare for it is your homework and the problems I did in class. All right? The homework problems and the problems that I lectured over. I have not made the test yet, so what I plan on doing is going through the homework sets, picking out problems, going through the class lecture videos, and picking out problems. But remember, all the videos I basically did, almost every single one of them, were based on notes that were handed out in class, right? Or that were in here in files. And they had examples that I worked. So if you just go back and look at the notes, look at the examples, you can work those on your own. Watch the lecture if you need to. All right? That's how I plan on building the test. Any questions? We good? All right, I've already taken attendance when I came by and checked everyone's homework. Please do not forget to bring your formula sheets. Because if you don't have them, you don't have them. So I'm going to wrap things up here. I'm going to go down to my office, and I'm going to be in my office till 5 o'clock if anyone wants to come by. Unless no one comes. If no one comes, I'm not going to hang out till 5 o'clock.
Are you gonna put an answer so we can just check after we're done?
How about this? If you have a question as to whether or not your answer is